So here's the warm-up, and because this is a short lesson, we'll really dive into this right here. Find the sum of the finite geometric series. All right? So, let's go ahead and write down what it would be. The sum is the sum of n numbers. 20. Let's go ahead and, let's go ahead and put 20. Sum of 20, n is 20. Is going to equal to, let's do the summation. The summation notation for it. Where we start with the first one. The first one to the 20th one in the sequence. Sure. And this that it is geometric. So what is A1? Let's plug it in already. A1 is 2. And then what is the common ratio? It's geometric, it's exponential. What's R? R is 2. And it was something to the power of what? N minus 1. And so there's the formula in summation notation. But there is a formula you're supposed to use, and we will do that in a minute. But we want to just really understand what's going on here. So you're summing up 20 numbers in that sequence. Okay? So what I'm going to do is I'm going to go ahead and put those. We're going to do it all. We're going to use a calculator. 1, 2, 3, 4, 5. And we're going to add the other one. That's 10. 11. 1, 2. That's how many we're gonna add. I'm just because we have time, and let's do it. Okay, so what would be the first number in that sequence? Well, A1, no? What's A1? A1 is given, and A1 is 2. So this is A1, A2, A3, A4, all the way to A20. A1 is 2. Okay? What's A2? Anybody, what is A2? 4. How do we know it's 4? You can get it two ways. Well, it's saying that A1 is 2, and you are multiplying it by 2, so it should be 4. If you really wanted to use the formula, we're going to jump on to n is 2, plug in 2. Okay? 2 minus 1 is 1. 2 to the 1 power is 2. 2 times 2 is 4. So this is going to be 4. What's the next number? And the answer is 8. Somebody's going to, I heard somebody trying to say 6. It is not 6, it's what? 8. 8, 3. 8, 3. What is 3 minus 1? 3 minus 1 is 2. And what is 2 squared? What is 2 squared? What is 2 squared? 4 times 2? Are we not 8? Okay, 8. And I hope you see a pattern here, maybe, or you can get a calculator. Get a calculator and see what's going to happen here. 2, 4 plus, what's 8 plus what? Come on. 16, no? Wouldn't it be 16? Come on. 32? 64. You guys got calculators. You can just go 64 and multiply by 2. 128. What else? 256. 512. Yeah, maybe it's too small. I don't think it's gonna. 512. Then what? 1,024. 2,048. 4,000 what? 4,000 what? 96? 8,000 what? I can't read. 40, 96 times 2? 8192? Times it by 2. I can't do this. 16,384. Now, you see the tediousness of this. Man, do I not? I'm going to stop already. Times it by 2. 32, 7, 68. Times it by 2. 65, 536. Times it by 2. 131, 072. Times it by 2. 262, 262, 144. Times it by 2. 524, 524, 288. Okay. I need this. All right. So that one's going to be times it by 2. 104, 104, 8, 576. All right. 576. So to actually complete this, to finish it and get an answer, the sum of 20, what are we going to do? Add them all up. Add them all up. Let's go. Get your calculators. 2 plus 4 plus 8. $128 plus 256 plus 2048 plus 4096 plus 8192 plus 16384 plus 768 plus, if you make a little mistake, man, 6.36, 131072 plus 262144 plus 524 288 plus 104. It did. I don't know if it's doing it for you. It's doing some weird stuff now. It can't get that last number. It's doing some weird stuff. Let me see. 104. I can't even see the number. I don't know what's it doing for you guys, but it's not getting the number. I'm gonna go ahead and delete this and then add the other ones. So the calculator is almost messing it up. Delete. 52428. 524,288. I need another 8. Yeah, I don't know what's up with this. I'm gonna equal that and then add the 104. Add the 104. 8576. What are you guys getting? What's the answer? What's the answer? Anybody? Nobody did it. So am I the only one up here just trying to do it and everybody's watching? Anybody? What did you guys get? $2,097,150. I'm getting here on this one. Now, of course, somebody always, like I said when we started this unit, what was it when we started the unit about adding up 1 plus 2 plus 3 plus on to 100? And so a teacher, 200 years ago says, hey, you know what, I'm tired, I want to teach, I'm just going to sit around, I'm going to sit down, and then you're going to just add 1 plus 2 plus 3 plus on. And what did one kid do? He's like, after 5 minutes, I got it. What? So you're going to thank somebody else who does not want to be doing what I did, and he came up with the formula. And for something that has a sequence of adding numbers that go in that sequence of something like what we had there, there's this formula. And the formula is the sum of 20 numbers is equal to A1. What is A1? And he said 1 minus 1 minus, and R goes there. What is R? The only problem here is where does the N go? On top or the bottom? So at N, what am I going to put here for N? 20. So now let's go ahead and do 1 minus 2. What's 1 minus 2? Negative 1. Negative 1. So let's have that already, and let's put this in the calculator. What's 1 minus 2 to the 20th power? 1 minus 2 upon 20 divided by negative 1. And then multiply that by 2. And I am getting So, would you rather be doing this, or would you rather be doing it plus, 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 plus? I think you would want to be doing it like this, no? So, hopefully, now you understand how they all are related. Is the sum of n numbers, if it is a geometric sequence, that you can add up all these numbers in the sequence, and it will equal to the formula. A1 equals parentheses 1 minus r to the power of n minus 1 over r. Plug in the numbers, work it out, and that's going to be the sum of 20. Let's move on then to the last lesson for today of this chapter. Lesson 8E, recursive rules for a sequence. The recursive rule for a sequence, what are they? It gives the beginning term of a sequence and a recursive equation that tells how a sub n is related to one or more preceding terms. And I just said now that today we're going to use it as much as a review for the test next week. Let's review some things. Gives the beginning term of a sequence in a recursive equation and a recursive equation. All right. So 8A was about this. 8A was about finding an equation for an arithmetic sequence, and that equation was something like a sub n equals A1 plus what? For an arithmetic sequence, what was it? A sub n equals A1 plus what? This is the first one we did. So that is some others, I forget what the name of it is, but we're going to come up with a recursive rule that will give you the sequences in a arithmetic sequence just like this one does. And the way you do it, and it goes like this. So there's this one, there's that's the first one we've done, and here's this number 2. That's going to be, you have to give one of the numbers in the sequence, and we usually do A1. So you have to give a number in the sequence, and then you have to give the rule for it. And the skeleton is just really just, all you do is just write down this skeleton. A sub n equals A sub n. There's so many formulas in this chapter. A sub n equals, what is it? A sub what? N minus 1, yes. I remember now. Equals, and so you got to put in some number here and some number here. That's all. So that's the skeleton. You have to give some number in that sequence. Put it here. If it's A1, you put it what's A1. And you're going to put the common difference here, whatever that common difference is. D, whatever that is. Everything else stays the same here. And it will give you, it's equivalent to this one here. The other one we did was the geometric sequence. And the geometric sequence was, what was that geometric sequence? Geometric sequence was a sub n equals, what was it for geometric? A1, was it A1? Yes, A1 times what? Rn minus 1. I think that's what it was. So there's the other one. That one's for geometric. So we only are doing arithmetic and geometric. And for that one is even easier. Why is it even easier? Because it would be this one. It would be that you have to give one of the terms again, usually A1. And the skeleton for it will be A sub n equals an minus 1. It is an minus 1. But where you're going to put in a number is going to be right here in the middle, in the front. Oh, just like right here. But it's going to be R. It's going to be R that you put there. What the? Ran. Oh, that's why it's ran. I remember it was ran. So there it is. So this is what you need to know. This, you need to know this. Okay. Let's go ahead and get started with this. Pretty easy. Recursive equations are arithmetic. A sub n equals an minus 1 plus the common difference, and you have to give one of the terms. Geometric would be a sub n equals r. You got to plug in a number for r times a n minus 1 ran, like you. I remember RAN, ran for geometric. N1. Oh, basketball. Ooh, N1. Nope, nobody. Oh, thank you. Somebody smiled. All right. You guys ready? Get going? Recursive equations, let's go. That's all you need to know. We'll just do them and then you'll see it. Here we go. Round 1. Write the first 6 terms. Write the first 6 terms of the following recursive sequences. This is actually really, really easy. It just looks difficult, but it's really easy. So you are given a recursive rule. The whole thing, this is it, where they give you a 0 instead of a 1, and they give you the formula for it. So it says to find the first 6 terms of this sequence. Well, let's get them. A0 is already given. Is this arithmetic or is this geometric? This one is what? It's arithmetic. It is arithmetic. So if it is arithmetic, you know, there was only 2 that I gave you. So A0 is what? So what would be the next one? What's the common difference? What's the common difference? So what am I going to do if it's arithmetic? Add 1 plus 4 is? Now to that number we're going to add what? Which is? This is easy. This is just, to 9 we're going to add what? Which is? Then what? 17, then what? 21. So to the previous number, we add 4 to get the next number in the sequence. The way I have it written down, it just makes it look weirder. It's like you don't have to be doing all that. You just know 1, 5, 9, and all that. All right. Let's do one for this type. Let's do one for that type. All right. All right, yes. Is this one arithmetic or is this one geometric? And the answer is that this is geometric. And you gotta, I mean, yes, that's the other one, no? And so now that we know that it is geometric, because it's multiplied. Why am I writing the rest? A1, I'm gonna write it again. A2, A3, A4, A5, A6. What's A1? 1. What is A2? What is A3? 9. What's A4? 27? A4. What the heck happened here? Oh, what? A1, A2, A3, A4, A5. What's A5? A1. What is A4? What the heck? I can't even read my own. A6. 243. Whatever. This is just kind of like sometimes some years I don't teach it. Sometimes I don't even go over this and whatever. This is like whatever. But this is another way of writing sequences. So the moral of this story here is that you have to give one of the terms in the sequence and give a rule for finding the rest of them. All right, let's go. Let's go to number 2. Yes, number 2. Now we're gonna actually have to find a recursive rule for this sequence. Okay, we only got two to choose from. Is it arithmetic or is it geometric? Or it could be neither, but then I guess there could be 3. I don't know. Which one is it? Arithmetic. Why is it arithmetic? Because you're adding 10 every time to get the next number. So whenever you're adding something, so it's going to be arithmetic. And so arithmetic went something like this. Let's just always give A1 if possible. You don't have to do A1, but why make it harder? And the skeleton is A sub n equals A sub n minus 1 n1. I'll remember n1, okay, because I cannot remember. You're going to put that D there. All right. What's A1? 3? A1 is 3? And what's the common difference? And we're done. That's it. You're like, what? Like, there's nothing, there's no math really anywhere involved other than just plugging in. So, yeah, you have to give one of the numbers in the sequence and give the rule or the equation. A1 is 3, the common difference 10. an equals an minus 1 plus the common difference, which you're going to plug in 10. And you're going to say that a recursive rule for this particular sequence is that a1 is 3, and that an equals an minus 1 plus the common difference, you're going to plug in 10. Let's go to number 3. Let's go to number 3. All right, here's number 3. All right, here we go, number 3. Write a recursive rule for this sequence. You're like, where's the sequence? Is the sequence generated by this equation, is it going to be arithmetic or is it going to be geometric? Take a 50-50 chance. One of those, is it arithmetic or geometric? Huh? Which is it? Arithmetic or geometric?
Geometric.
Geometric? Why? Because we already did arithmetic, so it must be geometric? It's actually arithmetic. How do I know it's arithmetic? Look, well, generate a couple of these sequence numbers, no? What would be A1? Anybody? What would be A1? Somebody said it. 2? Somebody say 2? Yes. Why? Because n is 1. If this is 1, then we plug in n, this is 1. Then 8 times 1 is 8. 8 plus negative 6 is 2. So yes, it is. If this is going to be A1 is 2. So what would be A2 then? What would be A2 in this thing? Did you say 8 times 2 is 8 times 2 is 16? It'll be 10. Yes. And let's do one more. Let's do one more. A3. What would be A3? 24 minus 6. What's 24? 24 minus 6. 18? So what are we constantly doing here? Are we adding what? 8. You see it? You see it now. Hopefully you see this. So we're going to say that this is arithmetic. So if it is arithmetic, so we're going to say that A1 is what? A1 is 2. Yes, because we already did get it. And then the skeleton is what? A sub n equals what? N1 was it? A n minus 1 plus, what do we plug for common difference? The common difference was 8. And we're done. You gotta give one of the numbers in the sequence and then the general rule after. A recursive rule for the sequence that A1 is 2, and then AN equals AN minus 1, sub n minus 1 is plus 8. Last one. Is there one more? I think, yeah, this is even easier. Last one. I'm good. It's got this. Last one. Write a recursive rule for the sequence. Is this going to be arithmetic or is this going to be geometric? Man, if this is the last one and I don't do an example with geometric, so what is it? Geometric. So if it is geometric, let's get a sub 1. What's a sub 1? You can just plug it in. If you plug it in, it's still going to be, it's 2. The answer is 2, no? So it's 2. And then the skeleton was a sub n, and I say a ran. What was it? No, ran. What the heck was it? R. We're going to plug something for R. and then a sub n minus 1. Yes. So we got to put the r right here in the front. What is the r? What is r? 3. And we're done. Give one of the numbers in the sequence and then put the 3 right there. That's it. Let's see. We got this. A1 is 2. R is 3. A recursive rule for this sequence that A1 is 2 and A sub n is equal to 3 A n minus 1. Okay, good. Let's see.